All right, this is Mr. Etheridge, high school math teacher at Rufus King International High School, coming to you with a homework tutorial. We're talking about exponents and specifically the division property of exponents and how that relates to looking back at time. So this is coming from our textbook, Discovering Algebra, lesson 6.5, looking back with exponents. So this is going to be a brief homework review. My algebra students, but of course this is on the internet, so anybody's welcome to watch and contribute. And so homework review. So we assign page 363, numbers 1 through 4. Numbers 1 through 4. So let's take a quick look at a few of those. Let's look at number 1. Number 1 says eliminate factors equivalent to 1. Equivalent to 1. So what that means is that they're the same in the top and the bottom, equivalent to 1. So let's take a moment to look at those and see what we see. So we want to see which ones are equivalent. So notice what they did here. We had x to the fifth. And we see x to the factor 1, 2, 3, 4, 5 times in the top. Y is the factor 4 times. 1, 2, 3, 4. X is the factor 2 times in the bottom. So that's why it's x to the second. Y is the factor 3 times. Y to the third. So that's the key point here. So let's knock out these common factors. We got x, so two x's are gone. And then looking at our y's, we were able to get rid of 3 of the y's. What's left? We have 3 x's, that's x to the third, 1 y times y, x to the third power y. That is how we do that first one. And so let's move ahead. Let's move on ahead. And remember, if you need to go back and take a look at this, you could always rewind. That's why I'm putting this on the internet for you. So you can look at it and then also back up, turn around, see it again, keep on moving. So that's why I'm doing that. That's the rationale here for you. That's the rationale. So number 2, numero dos. Use the properties of exponents to rewrite each expression. So mainly the division property, because that's the property we learned in class today. Remember what that property says. We said b to the m power over b to the n power equals b to the power of m minus n. Same base, and we subtract the exponents when we divide. So we got a few ways. We could expand it out, or we could use the property. I'm not going to do all of these because this is your homework here. So let's look at b. We have x to the power of 11 minus 5. What's 11 minus 5? You said 6, you're correct. This is x to the power of 6. I'll have to throw a box on it at the end. So then let's do one more together. Let's do d. So 7 over 14, that's simplifiable, ladies and gents. 7 over 14, how can we simplify that? They have a greatest common factor of 7. So what's 7 over 14? Waiting for you. Oh, you got it. 1/2, 1 over 2. And so let's simplify these x's. X to the 6 over x to the third. How many x's are left? Exactly, x to the third power. Now what about these y's? We have x to the third power in the top, y to the third power in the top, y to the first power in the bottom.
Would a member of the engineering staff please come to the attendance office and see Mr. Fink? Would a member of the engineering staff please come to the attendance office and see Mr. Fink? Thank you.
Pardon that interruption. I'm using the free software at the moment, so I can't edit that announcement out. I'm still at school. It is what it is. And so y to the third over y to the first, that just leaves y to the second. Throw a box on it. And there's our answer for 2B and D. There we have. You also could write this as a decimal. You could also say 0.5 x to the third, y to the second. That is also acceptable. That is also acceptable. 3. Cal. Cal and his wrong math here. Cal says that 3 to the 6th power over 3 to the 2nd power equals 1 to the 4th power because you divide the 3's and subtract the exponents. Al knows Cal is incorrect, but he doesn't know how to explain it. Write an explanation so that Cal will understand why he is wrong and how he can get the correct answer. So here we want to dive in and see how can you help him do this. And I would break down what the factors mean. I would say, okay, 3 to the 6th over 3 to the 2nd, and the top means 3 times 3 times 3 times 3 times 3 times 3 over 3 times 3. And so we see what common factors there are, and of course you will write this in words. I'm just giving you the visual here. You need to write this in words, so there's still some for you to do. And so you'll cancel these, and we see it's 3 to the 4th. And so you need to break down, okay, I would say in words, 3 to the 6th means that 3 is a factor 6 times. And 3 to the 2nd means 3 is a factor 2 times. And then, thus, 3 is left as a factor 4 times after you divide it. And I would write all that in words. But I'm going to leave that for you to do. Don't worry, if you need me to go back and do it, just hit that rewind button and hit play again, and you got it. Let's move on to the next one. Number 4, that was the last one from the homework. We got a few word problems. This is about Webster, not from the dictionary, but just Webster. Webster owns a set of antique dining room furniture. That means it's old. Antique dining room furniture has been in his family for many years. The Historical Society tells him that furniture similar to his has been appreciating in value at 10% per year for the last 20 years. And that his furniture could be worth $10,000 now. Which letter in the equation y equals a times the quantity of 1 plus r to the power of x could represent the value of the furniture 20 years ago when it started depreciating? So that would be the starting value. Which one of these letters is the starting value? Which one? A, exactly. A represents the starting value. That usually is the case for our books. So I will write that. I would say the letter A. That's what that is. B, substitute the other given information into the equation. We want to plug and shove. We want to substitute what we know. We want to show what we know, but we don't know how much it was worth initially. But A is how much it was worth initially. But what do we know? We know how much it's worth now. We know how much it's worth now. How much is it worth now? It's worth $10,000 now. So we say 10,000 equals, we don't know what A is, times the quantity of 1 plus, we want to say our rate as a decimal. What was that rate? It's up there in the top. What was the rate? Let you think about it for a second. 10%. 10%. So what's that as a decimal? 1 plus 0.1. And how much time has went by? What's our exponent? X is equal to what number? X is equal to what number? 20. 20 years have went by. And so solve your equation to find how much Webster's furniture was worth 20 years ago. Show your work. So I'm going to leave that for you. This is simply a tutorial, not a complete walkthrough, but we need to find A. We need to solve for A. And now this is solving. All you do is you do your exponent, you solve, and you get an answer. You get what A equals. You'll find what A equals. You'll say A equals some number, and then you will say it was worth blank dollars 20 years ago. Thank you for tuning in. Glad you could check it out and keep being great. You're super.